Today's notes are about standard form of quadratic functions. We've talked about vertex form before, but let's investigate this form. F of x is equal to ax squared plus bx plus c. This is known as standard form. Notice it's made up of three terms. We have a quadratic term first, a linear term second, and a constant term third. I know it's a quadratic function because the highest exponent is 2. So I know it's definitely not a line, otherwise that would just look like bx plus c. This is called standard form, and I can easily see all three terms here. The problem is, where is the vertex? In vertex form, we had a really nice way of seeing it very easily. In standard form, it's not so easily seen. Luckily, we have a way of finding our x and y coordinate of our vertex, even when we're in standard form. If I can recognize a, b, and c, then I know that the x coordinate of the vertex is equal to negative b over 2a. So I can pretty much just take it as a formula now. We will discuss later where this comes from. So if I know a, b, and c, I know that the x-coordinate of the vertex is negative b over 2a. How do we find the y-coordinate of the vertex? Well, if I know the x-coordinate of a point, all I have to do is plug in to find its corresponding y-coordinate. So all we have to do is find f of negative b over 2a. All we're doing is plugging in the x-coordinate to our function. So even though we're in standard form, we have a way of finding the vertex fairly quickly. Let's do an example. Here we have a quadratic function, f of x equals x squared minus 4x plus 3. It's in standard form, and I can even state what a, b, and c are. A is our leading coefficient of our quadratic term. In this case, it is 1. We have a 1x squared out front. B is our leading coefficient of our linear term, which is negative 4. And c is our constant term, which in this case is 3. So, let's use our formula we just talked about, negative b over 2a, to find the x-coordinate of our vertex. Negative b over 2a would be negative negative 4 over 2 times 1, which becomes 4 over 2, which is 2. We're not done though, we need to find the y-coordinate. So I would like to plug in 2 to our function. I need to find f of 2. That would be 2 squared minus 4 times 2 plus 3. And that gives us 4 minus 8 plus 3, which is negative 4 plus 3, which is negative 1. Therefore, our vertex is at 2, negative 1. Look at all that work we just did just to find the vertex out of standard form. I wish that this function was in vertex form, but it wasn't, so we had to work a little bit to find the vertex. Let's plot that vertex before we forget it. 2, negative 1 right there. Let's get some other points on this parabola. Same method as when we had vertex form. I like to plug in some x values near the vertex. So let's make a table. I know that the x-coordinate of our vertex was 2. So I'd like to plug in 1 and 3 and 0 and 4. I like to kind of surround the vertex when I'm plugging in. I got a freebie. I already know our y-coordinate when x is 2. So all we have to do now is a little bit of algebra, a little bit of simplification to get the other ordered pairs. If I plug in 1, let's see, 1 squared minus 4 plus 3 gives us 0. I know that we have some symmetry in our parabola, so I know that the point immediately on the other side of the vertex is also going to have the same y-coordinate. If I plug in 0, 0 squared minus 4 times 0 plus 3 is 3. And I can use the idea of symmetry to fill in that other missing value. You can also use the axis of symmetry. I know that the axis of symmetry has to be x equals 2, because I know that the function is symmetric about that vertex. So if you plot in that dotted line and start plotting these points, you'll see how the symmetry works. 1, 0 was right here. Oh, that means we also have the point 3, 0. I hopped over that line of symmetry. 0, 3 was right here. Oh, I can hop over the line of symmetry and go the same distance to get a corresponding point. I can then smoothly connect those points to get our graph, just like we did in vertex form. So instead of having to plug in 5 numbers, 0, 1, 2, 3, and 4, I really only plugged in 3, and I got the other 2 by using reflections. So that's how we would get a sketch of our function in standard form. Let's stick with this function, and let's investigate a couple of other things. What if I was interested in the y-intercept? It's pretty nice to find this in standard form, because I know I'm just going to plug in 0 for x. Just like we would do with any other function. F of 0 is 0 squared minus 4 times 0 plus 3, which is 3. Our y-intercept was 0, 3. You might have noticed that we actually already knew that point from the previous slide. We had already graphed it. But I wanted to purposely do this without looking at the graph so you could see how easy it is to find the y-intercept. These first two terms will always go away when you're plugging in 0. So you'll notice that that y-intercept is always that last guy, as long as we're in standard form. What else could we find? Let's find some zeros. Those would be x-intercepts. Again, I could look at the previous slide to see them on the graph, but I'd like to solve algebraically. In order to find the zeros, just like for any other function, we are going to solve f of x equals 0. Remember, zeros are x-intercepts. All right, our function looked like this. We set it equal to 0. We have a quadratic equation. We know how to solve quadratic equations. We would have to factor. So I need two numbers that multiply to 3 and add to negative 4. And those numbers are negative 3 and negative 1. I now can set each factor equal to 0. And I notice that x is equal to 3 or x is equal to 1. So our zeros, we're at 3, 0 and 1, 0. And again, if I flip back a slide, you'll see that indeed the graph crosses the x-axis at x equals 1 and x equals 3. Well, it was our lucky day. We had a factorable quadratic equation. What if we couldn't factor it? There's other methods we can use to solve a non-factorable quadratic equation, such as quadratic formula, or maybe we could even use the help of our calculator. Let's look at one last example going the other direction. What if I give you a function? Can you write the equation? And can you write the equation in standard form? The first thing you might notice is that this function has a vertex at negative 3, 2. The other thing you might notice is there's some other nice points on this function. I'm going to list one out. The function passes through and I like that point, negative 2, 4. Using these two pieces of information, we can write the equation. So I think the easiest thing to do here is start with vertex form. I know that g of x is going to be equal to some a value times x plus 3 squared plus 2. This is a quadratic that is shifted left 3 and up 2. But notice I don't know what a is, so I still have that a as a placeholder. That's why I wrote down that other point. I know what g of negative 2 is. G of negative 2 is equal to a times negative 2 plus 3 squared plus 2, and I know that g of negative 2 is equal to 4. We're using this point, plugging it in, negative 2 for x and 4 for y, and that's going to allow us to solve for a. Let's simplify. Negative 2 plus 3 is 1, 1 squared is 1, plus 2 is 4, so we get that a equals 2. We're almost there. I now know that g of x is equal to 2 times the quantity x plus 3 squared plus 2. Well, that's vertex form, but the question was asking us to find g of x in standard form. All we have to do now is multiply this out, and this is a real test of order of operations. Exponents come first, so I know I have to multiply out x plus 3 times x plus 3. When I do that, I get x squared plus 6x plus 9. Notice I still have that plus 2 on the end and the 2 coefficient out front. I now have to distribute that 2, and we get 2x squared plus 12x plus 18 plus 2. I just simplify those last two terms by combining them because they're like terms. 2x squared plus 12x plus 20. We did it. That was equal to g of x. Let me circle my final answer, or put a box around it. And let's think about what we did. We used vertex form because it's usually easiest to first find a function in that form. We had to worry about the a value. That's usually the part that's the most confusing for students. We can't assume that that a value is 1. We used another point to solve for our a value, and then we multiplied out to get our function in standard form. So standard form isn't super helpful for things like finding the vertex, but we do have a way around it. We can use negative b over 2a. Standard form is kind of helpful for seeing the y-intercept. Standard form isn't super helpful for seeing the zeros, but if I know how to factor or solve a quadratic equation, then it ends up being not so bad. Good luck with standard form.